Just wanted to mention that in these tutorial videos, I'm just kind of running off the top of my head. I don't have a script or anything I'm running off of. So you kind of see my natural flow of development, and I will double back and correct things, or if I see something that can be improved, I will improve it. And I apologize if that's not the kind of tutorials that you like, but if it is, you get to see some of the decisions that I make and mistakes that I make and how I correct them along the way. Hope you enjoy the video. Welcome to video 4 in our series on creating the impossible game. So we're going to just be doing a lot of polish and level building in this episode. So let's get started. First thing we need to do is get prefabs created out of all of our items here. We've already done with our triangle obstacle. We can go into our prefabs and we can drop in one of our square obstacles. And we will call this kill zone for the little black squares. So if you touch them, you just die. And we've got those in here. Next, I want to create another script for dealing with like global variable type things. So we'll have essentially a game manager. This will be a place that we can change speed and everything like that in one location and not have to worry about doing it in all of the obstacles. So let's go to C# script. We will call this possible game manager. And go back and get that to load up. Let's open up our impossible game manager script now. And we want to add a float, movement speed. Whoops, spelled that wrong. And set that to equal to 7. And we're going to make that public so we can access it from outside. Now, if we jump over into our obstacle movement controller, rather than having this public float here, we could have a impossible game manager. And we will set game manager, or game manager, is equal to game object dot find game objects, the game object with tag. And we're looking for the one that is tagged game controller. And we're going to get component impossible game manager. And now we have a reference to that. So instead of using this movement speed here, we can say, hey, let's get our game manager dot movement speed. Now if we go back into Unity, we can create our empty object here, call this game manager, give it the tag game controller, which is the tag that we were referencing in the script here when we were an obstacle movement controller, saying we're getting game object with tab game controller. It's because we've created this impossible game manager and attached it to this game object that's called game manager with the tag game controller. So now we just add our script to that, and we have our movement speed. So now if I go in and we actually play, we'll see everything's moving, even though they don't have their own script anymore. I can make that jump. Nope. I need to adjust these values. All right, so now this is working correctly, and if I go here and like say pause it, and I change the game manager speed to like, let's say 10, and unpause it, it's not, we're reloading the whole level, so we're not actually going to see the change. But if I change it here to say 12, and then we unpause it, you'll see that we're moving considerably faster, and then we're slowing down when the level reloads because it's reloading the original values. Now that we have our game manager here, we can play with a few values. I think 7 is too slow. I think maybe 11 might be closer to what we're looking for. Oh, didn't jump. There we go. Yeah, that looks about right. And now we can, if we had stacks of 2 there, we could clear them. So I think we need to adjust the hitboxes on the squares here. So this secondary, the trigger is, I think, maybe a little bit too high, and it shouldn't be on this side because the box, our player is rolling off the side of it and catching that. So we will adjust it so the X size can come down a bit, and then we can shift it to the left, and then make it a little bit shorter. Whoops. Maybe half the height. Put like right there like that. Bring it in just a little bit more. There we go. So that should be considerably better. We'll test it real quick. Yeah, that's a lot better. I'm not worrying about hitting it every time now. All right. We have one more quick obstacle to make, which is just a combination of our existing obstacles. So if we take one of these and Control CV, duplicate it, we can put two spikes together like that, which is a very common tactic inside of the Impossible game. And let's figure out what the other one is. We'll just drag this one down here, and then we can create an empty, call this double spike, and we'll drag these two in. And now we can make that as a prefab, and now we have an easy way to drag in our spikes here. So now that we have that, we can start working on our level. And to make it easier on ourselves to work on this level, I'm going to take this ground sprite here. I can get a hold of it, and we're going to duplicate it. And this one is going to be, call it hidden ground sprite. This one, we are actually just going to scale it on the x-axis by like 100. Now we have a ground layer going all the way across that we can easily see and know where we are in relation to that. And then we'll just hide it when it's time to actually play the game. So let's grab our pieces and kind of get this level laid out to how we want it. After working the level a little bit and trying to build this out, I'm sure you noticed a couple of issues as well. So what we're going to do is kind of reorganize some of these things to make it a bit more user-friendly and easier for us to modify during runtime. So first, if we actually place all of our pieces here inside of a game object called level obstacles, we don't have to do the obstacle movement on any of these items. We can actually do it on just level obstacles, which is going to save some performance as well as give us the ability to restart the level without reloading the scene. So when we reload or die and we go back to the beginning, it's going to be the same scene. So any values that we have adjusted at runtime to kind of get a better feel for the level will still be there. So what we're going to do is select each of our prefabs, which we don't need to do the double spike because it's inheriting from this one. So if we go into triangle obstacle here, we can just remove the obstacle movement script. Go into the square object, remove the obstacle movement script, and kill zone as well. Remove optical movement script. And now if we go back, we can go and grab our level obstacles, add obstacle movement. And now if you press play, it'll still work the exact same way. You won't notice any difference. But the difference now is that rather than actually resetting the level where we have on die, we can reload the, essentially move the player back to the starting position and the level back to the starting position. So we just get a reference, so public game object, and we'll call it a level group. We're going to want to move that back to the starting position. So what's probably the best way to do this is going to say, hey, level obstacles, I want your position to be 0, 0, 0. And then we'll grab everything inside of here. We'll move it up, get it on that line, and get it looking right. And now, whenever we die, instead of reloading the level, what we'll do is we'll take our level group, dot transform dot position. It's going to be equal to a new vector 3, dot, or we'll say equal to vector 3 dot 0. So no more loading. We'll just restart it. We just have to create a reference. So our player has, so the reference is actually on the player killer controller. So what we'll do is we'll add it to the game manager. So we'll use the possible game manager here. And we'll say public game object level group. This way we can access it from anywhere we are. So inside of the player killer controllers, we'll have our level group, and we can, instead of making that public, we can make it private and say level group is equal to game object dot find game object with tag game controller dot get component impossible game manager dot level group. So at start, all of the obstacles will reach out to the impossible game manager where we were storing the level group and get it set, and then level group dot transform dot position is going to be equal to vector 3.0, and that should do it. So we just have to come in here now, and once it's done loading, we'll just create our reference. So if we grab our game manager, we've got our level group, so just grab our level obstacles, press play. And now rather than reloading the scene, it'll just reposition, which we did not do something right there. What's happening there? We have our square obstacles. Why are some of those still moving? This one still has an obstacle movement control on it, so I'll just remove that. All right. This one isn't a part of the prefab is the problem, so I'm actually going to delete and just duplicate this one. There we go. Now, if we press play, it should actually work. Everything's moving at a speed, resetting nice and smoothly, and working how we want it to work. But if we go through and now, I got stuck on the ground somehow, but if we go into our game manager now and we adjust our speed or something like that, it will stay and we can continue testing with it. Another nice feature to add is when you do manage to beat the level, when you're testing an area, we are unable to just kind of go back and try it again. We have to completely reload the level if we make it past, because the game just kind of continues going. What would be nice is if we can set a restart button, essentially. So if I get to a situation like this, rather than having to restart the game, we can go back to the beginning. So we'll tie that to the spacebar. So if we go into our player controller, we can add another reference here, say if input.get key down, and we do key code dot space. We'll get anytime our space is pressed down. At that point, we essentially want to just reset all the positions. We're already doing that in the player killer controller. So what we could do is, instead of calling this in multiple ways from multiple places, we could just place all of this logic inside of the game manager itself and then just call it from there. To do that, we'll just essentially take this from here and Control X, go into the Impossible Game Manager. Let's get rid of all of this. We don't need any of this boilerplate code. And we'll say public void reset scene. Or we'll call it reset position so it's not confusing. All right, so all it's going to do is grab its level group, transform position vector 3.0, and then inside of here, we say, instead of game object level group, we will do impossible game manager. And set this to equal to this without the level group. And now we have a reference to the game manager. And in here, we say game manager dot, reset positions. And then we can do the same thing on the player controller, which I think, nope, we don't. So you can just copy this from the player killer. So in start, and grab the reference to this. And then whenever we press space, we want to say, hey, game manager, I would like to reset positions. All right, now if we test that out and press play, everything's working. And if I make it a little ways in, if I can make it a little ways in, I'm not very good at this game. Come on. Now I press space, I go back to the beginning. And you can see that happening over and over. And that's a good way to reset this, and we'll actually be able to tie this into the flag system that they have later where you can lay flags down along the way. Next problem to work on is that we kind of keep getting stuck in the ground. You'll notice that sometimes when we jump, the player clips into the ground. And that seems to be because of the hard corners on the box collider. So to work on that, if we go into our player square here, we have this option called edge radius. Zoom in here to look at our player. And if we add the edge radius, you'll see a secondary collider appears with rounded edges. And those rounded edges do a lot to prevent the clipping into the ground. So if we add this up, let's say 0.3, and then we pull down the size until it fits right around the box. So that's a little bit too much. Let's pull it down to like 0.14. And just kind of play with this until we get it to fit about how we want it to be. And that looks pretty decent for the square. So now, if I go in and I press play, not only is the player not going to clip into the ground, the jumping is a bit more responsive when landing on things like this. So we don't have that issue of like we're hitting a corner and it bounces. It has like a nice roll to it and kind of lets us jump and continue on. But no more clipping to the ground, so another problem solved. So another problem is that the camera doesn't follow the player off the screen. To solve this problem, we could build our own camera follower, but we can also just go into Windows, Package Manager, and grab, I think it's Unity Registry, and grab Cinemachine camera follow. So you can just search it up here. Cinemachine right here. Go ahead and install that. And this is just essentially any camera functionality you can imagine. It's this whole package that has camera follows. You can use it to create first-person cameras, cinematic cameras. It's just a really great tool to use. Once we have that installed, if we go to right here, right-click, and say Cinemachine, we can add a free look camera. And you'll notice once you add it, there is a icon that appears next to the main camera. That is the Cinemachine brain, just being added to it. Just the free look or any of the Cinemachine virtual cameras have to have a camera to kind of correspond with. So now that we have that, we need to change a couple things in here. Just delete these axis names, because what will happen is if you can set the speed to 0 just to be extra safe. If the camera detects movement on those axis names being the controls built into Unity or customized within the input manager, it'll actually cause the camera to rotate. We don't want that to happen. So next we want our orbits. We want to set this to lock to target with world up. So now if we go to game and press play with those settings set, we do not see our camera. What is happening there? We need to set our follow target. I completely forgot to place it in there. So if we put player square into the follow and now press play, it will follow the player correctly. So now we can see it. It's super far out, but we can make these adjustments now. And you'll see the smooth up and down movement from the damping, which we can adjust more. But the more important part is it will follow those obstacles up into the air. So we can adjust things now. If we stay in game mode and we find our camera here, so we've got our lens ortho size, we can bring that way in. And what we want is this cube to be more towards the back of the screen, but we can't move our camera anymore because it's being controlled by the Cinemachine, and it's set to follow an object. So what we can do here is add a game object. Let's go ahead and create an empty, and we'll call this, let's say, player follow. So what this is going to do is we're going to actually position this out in front of the player and have the camera follow this object instead. So we just need to create a quick script to have this object follow that. So we'll call this player follow. We could try to anchor a game object or parent one to this, but because this is flipping, the camera will flip trying to follow it, and that's not what we want to happen. So we'll work on this player follow. And all it's going to do is have a reference to the game object. So public game object player. And we're going to say, or actually add a float here. So a public float x offset. So this is the amount that it's going to be offset. So we can actually slide this forward and have the camera following it with the player farther in the background. And then we'll say this dot transform dot position is equal to player dot transform dot position plus new vector 3 We want to set our X offset, and then 0 and 0. Now, if we go back into our Unity engine here, and attach this to our player follow here, and then set our player to the offset, or to the player, and then our camera, our virtual camera, to have it follow the player follow. We press play. We'll see that the camera is still following and still going up and down as the player jumps. But if I go into the player follow and change the offset, we can put the player towards the back. Might be a little too far. We can set the player where we want them, put them close farther to the back. And now we can see more of what's in front of us while we move through the screen. And then we have the value you want. So let's say like it's right here. You can right click, copy component, stop, and then paste component values. Now it looks like the X offset's working great. We should add a Y offset as well, so we have a little bit of customization there. So we'll just do the same thing and put that in the Y. And now go back into Unity once it loads. And we can select our player square, or our player follow, and we can adjust our offset here. So if we press play, we can lower the camera a bit because I think it's a little high, and put it like something like there. Because I didn't like when we were jumping that we were losing track of the bottom here. But that looks a lot better. Maybe a little bit more. Right about there. All right, and again, go ahead and copy component, paste component values. And we can add another script here. So we've got our hidden ground sprite here. This is the line that we made massive so we could see it. We can add a script for this to automatically disappear on play. So what we'll do is, oh, I didn't name that. Delete that and try again. Create C# script, and we'll say hidden ground controller. And in here, we'll just say on start and get component sprite render dot set enabled is equal to false. So on start, it'll just disappear. We just got to add it to our hidden ground sprite here. No matter where. There we go. So it's going to reach out, it's going to find the sprite render, and it's just going to turn it off. So now we just have the small line that is on the screen. But now it looks like the line is off center. So to fix that, we'll just go into our game scene. We can hide this for a second. Grab our ground sprite, there it is. And we can adjust the position a little bit. So let's move its position on the x-axis to something like this. I think it might be a little small, so we can scale it out just a bit. Now, if we press play, we have a much better line there. We can still move it to the right a little bit if we'd like. So let's take the position. Something like that. And copy component. Copy component, stop, and then paste component values. The last thing I want to add is I want to adjust the jumping script here to jump whenever the mouse is down, not just every click, but whenever it's just down. So if we just say get mouse button, so it'll just register that the mouse button is down at all times. And then if it is, it'll do its checks for if an error. So now this will allow us to jump continuously, which could be useful in certain situations when like jumping up the stairs and things like that. So now if I hold it, it's going to toss us in the sky about 1,000 feet. So what we need to do is say in air is equal to true, kind of trigger that for it. And then next time it touches the ground, it'll automatically bring that in. So we can check again and see if that worked. So now we can do our jump. and just hold down and bounce along. And this will be useful for areas like this back here, where if I just want to jump and hold down, it'll try to jump up there without me having to mash the button to make it. If I can just get my jump right, then I will make it up that staircase, but probably not because I am terrible at this game. And that about covers it for this tutorial. We're going to, in the next video, go through and like add the menus in and then the checkpoint system for the flag. And thanks for watching. I hope you're enjoying the series so far, and let me know if you have any recommendations for series to make in the future or anything like that. Thanks for watching.